Hello students, welcome to the fourth lecture of atomic structure of the atoms. In this lecture we are going to discuss the composition of the atoms, how we are going to represent the composition of the atoms that we are going to discuss in this lecture. Myself K.K. Mukherjee in the Science with Mukherjee's YouTube channel. So today's we will concentrate on the structure of the atoms. Suppose there is one element we have been given, that is the X. The normal name symbol of this element is X, and this element is having number of protons. Protons are suppose 12, and it is having the neutrons is 12, and naturally as it is a neutral atom, and there must be the equal numbers of electron in this atom. So electron will be 12. So what we have to do? We have to represent. This is basically the composition of the atom. Composition atom means in which subatomic particles this atom is constituted, and how to represent that we are going to discuss in this video. For that we have to know some basic definitions. Number one, that is the atomic number. Atomic number is represented by the symbol, that is the Z. Atomic number is basically the number of protons present in the nucleus. So you can write, it is defined as number of protons in the nucleus. Number of protons in the nucleus. So for this element, its atomic number will be Z equal to 12, because in this element you can see that protons are only 12. So second thing that we need to understand, that is mass number. Mass number is represented by the capital A, and it is basically the nucleus, the charge of the nucleus, positive charge of the nucleus is basically depend on the how many protons present in the nucleus. But what about the mass? The mass is basically being governed, existed in the neutrons, number of neutrons and number of protons. So mass number is basically, you can write sum of total numbers of protons. Suppose this is, we are taking this as P, and number of neutrons. Number of neutrons, that is N. We already know numbers of proton is the atomic number. So we can write here Z plus N. Z is the atomic number, N is the number of neutrons in the nucleus, and that is equal to the A. So when we are going to when we are going to decide how many neutrons in the atom is there, so there is a formula you can see, that is N, that is the number of neutron, is equal to A minus Z. Okay, this is the equation. From this equation you can actually able to calculate. And now how do we represent in the element all those things? Suppose this is the element. So in this element you can see that is the mass number. What is the mass number here for this element X? Z equals to 12 and A is equal to your 24, because it is the total number of protons and total number of neutrons. For the representing this in the element, so we have to know the symbol. First we have to know the symbol of the element, normal symbol of the element, and in the place is superscript and this place is the subscript. In the superscript you have to write the mass number. In the subscript you have to write the atomic number. So you can see here, so you can represent the number of protons and number of neutrons. In this case that will be X. You can write mass number is 24 and its atomic number is 12. So we can represent like this way. In the left hand side superscript, this is a superscript position. Left hand side superscript, you have this mass number, and left hand side subscript in this will be the atomic number. So this is how we can able to express the composition of the atoms in this type of forms. In this case you have to first see the symbol, and after that in the left hand side of the superscript you have to put this mass number. In the left hand side on the subscript you have to put the atomic number. So this is how we can able to write this. Now we are going to discuss very important thing, that is the isotopes and others. What is isotope? Isotope, atoms of the same element, atoms of the same element having identical atomic number but different mass number. This is called the atoms of the same element having the identical atomic number but different mass number. This atom we will call the isotopes. In many elements, as for example hydrogen, as for example chlorine, as for example your carbon, you have seen the isotopes, different type of isotopes, and we are taking the case example of the hydrogen. Hydrogen having the three isotopes, that is, one is your protium. Here you can see mass number is 1 and atomic number is 1 and mass number is 1, protium. Then deuterium, and the third isotope is 3,1. This is tritium. This is the three isotopes of hydrogen, and this isotope, that is the bulk amount. If we see the number, suppose proton, number of proton is P, and number of electron, suppose you are taking is E, and number of neutron which is N. Okay, so for the protium you can see that is the atomic number is 1 and its mass number is 1. So it will have the proton 1 and electron 1, but there is no neutron. There is no neutron. In the deuterium you can see there is 1 proton, 1 electron, 1 neutron. In the tritium you can see the 1 proton, 1 electron, but there is a 2 neutron. So you can see the resins of the isotope is basically the neutrons, difference in the neutrons. When the neutron is differ in the same element, you will find different types of mass. So here the resins is the difference in the neutrons. In this way you can see the carbon also there is 3 isotope C6, H12, C6. These are 3 isotopes of the carbon, and you can see everything is same, that is its proton, its electron is same, but only difference is here. What is the difference? Difference in the neutron. Here in this case, where the atomic mass number is 12, you can see that neutron is 6, here it is 7, and here it is 8. So there is a difference of the number of neutrons going to play the role in deciding the isotope. Okay. Now we are going to understand another very important thing that you can see, that is a different, that the elements will have the same neutron, but there are other things, that is atomic mass, atomic number is different. They are called the isotones. Isotones, atoms of different element, atom of different element having different mass number, or atomic number, you can say atomic number, but same number of neutrons, This is called the isotone, that is different from your isotopes. Example, you can see carbon and nitrogen. What you find? The atomic number is different, mass number is different, but there is here in this case you can see number of neutrons. What is 7? Here also you can see number of neutrons is 7. So this is a very interesting thing, that you can see the isotones, number of neutrons are same, but atomic number and atomic mass is different. Okay. Then there are another type of thing that we isobars. Isobar, it is basically the atoms of different element. Atom of different element having same mass number but different atomic number. Example, you can see argon, it is mass number is 40, atomic number is 18. Calcium, you can see mass number is 40 and it is atomic number is 20. So you can see the mass number is same whereas the atomic number is different. So this we call the isobars. Another thing that is important that we will discuss, isostars. Isostars, what is this isostars? Isostar is basically the number, it is basically molecules of different substance having same number of molecules same number of atoms, which is not molecule, atoms and electrons. As for example, CO2 and N2O. You can see number of atoms is 3 and you can also found that it is having the electron is 6 plus 16, that is 22, and here also you can see it is 14 plus 8, this is 22. So these are the isotars. So we understand the isotopes, isobars, isotones and isotars. So let us have some examples which type of question that may come in your examination that will make you much more clear about this concept. This is a question: from the following nuclei, choose the isotope and isobars. In that you will find the some combination will fall in the isotope category and some will fall in the isobar category, and you have to identify which nucleus will see this type of things. So if it is isotope, then what is going to happen? Its atomic number will be same. So you have to see the atomic number of these two. When atomic number is same, at that time when the number of proton will be same in the nucleus. So here is 8 protons and 88 protons. So we can say these two nuclei are isotope. And you can see here also that for the isobar it will have the same mass number. So you see mass number will be here 40 and is also 40. So this will be isobars. Okay. So this type of question going to come and you have to answer it. Element have atomic weight Z. Consist of two isotopes Z-1 and Z+2. The percentage abundance of higher isotope is, option is given 25%, 33%, 66% and 75%. For that, the element have the atomic weight this and it is having, suppose then we have to assume let the X percentage is the abundance is the abundance for higher isotope. Higher isotope, that is Z plus 2. Z plus 2 is the heavier. Higher isotope means heavier isotopes. Heavier isotopes. This percentage you have to calculate. How do you calculate that? It's very simple. Z plus 2 into X percentage. This is with X means Z minus 1. That is another isotope. Z minus 1. This will be 100 minus X divided by 100, and that will be Z. And you will calculate this and you will find that X will be 33.3%. That is the answer. And the B is the answer. So that is all for today's video. In this lecture, we have discussed about the isotopes, isobars, isotones and isostats, atomic number, atomic mass number, how do we represent in the element, that we have understood, along with some questions that this type of questions will come in your exams. And that is all for today's video. Hope you enjoy this video. If you like this video, you can share to your friends. All the best and be best. Thank you.